Yeah.
Thank you. Okay, so let's just do a quick recap of what we learned yesterday. Virtual private cloud, VPC, right? So VPC is one of the fundamental ingredients of AWS cloud, and anything that you do will have a touchback on VPC. So it's very important you learn what a VPC is thoroughly. What is VPC? VPC is a virtual private cloud that helps define a logically isolated, dedicated virtual network within the AWS. Right? I gave you an example of how a private network would look like, and if you were to extend your private network to a public cloud, that's when you need a VPC, or not necessarily. I mean, if you want to start fresh on a public cloud without any private network of your own, you can still build a VPC, and VPC is required for you to provision an EC2 instance or RTS or services that depend on VPC. And VPC is a private environment for you to build your own network within the cloud as if it would resemble your private network, which is completely in your control. And it also isolation between the VPCs from that belong to you versus other customers or other accounts. Okay, what and then we also learned about the CIDR IP addressing construct, right? What is a CIDR? Classless inter-domain routing, right? I also gave you a Wikipedia article to read about the CIDR, and there's also a CIDR.xyz. It gives a very nice pictorial representation of how the IP address ranges look like along with the subnet mask. So what does a VPC support? VPC supports and a CIDR block of a minimum of /28 and a maximum of /16. Okay, so that's something that you need to remember, right? If somebody asks you, is it possible to create a VPC with a CIDR block of /8? The straightaway answer should be no, it is not possible, because AWS supports a maximum of /16 and a minimum of /28. Okay, and it supports IPv4 and IPv6. We also read about what an IPv4 and IPv6. IPv4 is the old generation IP address scheming. IPv6 was then brought in order to meet out the limitations of IPv4 in terms of the IP addresses that are at the verge of exhaustion, because the number of devices and the number of networks in the world have increased, and the IPv4 is not able to support that. It's exhausted. VPC spans all the availability zones of an AWS region, right? We also saw that if you take a VPC, within the VPC, you have multiple different availability zones, and you can create subnets in the availability zones, and subnet is one-to-one related with the availability zone. Okay, it's always remember that when you provision an EC2 instance, you provision that VPC EC2 instance within a subnet, and that subnet is tightly coupled with one associated with one availability zone. So that way, you are indirectly provision instance in an availability zone by choosing the right subnet for you. VPC can contain one or more subnets in each availability zone. You can create any number of subnets within an availability zone, right, within the VPC. When you create a subnet, you specify the CIDR block for the subnet, which is a subset of the VPC CIDR block. Okay. Yeah, we also saw that yesterday, right? When you look at the VPC range, VPC is the superset. A subnet, which is also called subnetwork, is a subset of the VPC CIDR block. Each subnet must reside entirely within one availability zone and cannot span zones, right? I mean, a subnet is one-to-one related availability zone, right? It cannot span multiple availability zones. So you need to create multiple subnets for each availability zone. AZs are distinct locations that are engineered to be isolated from failures in the other availability zones. I give an example of Mumbai. If one AZ is in South Mumbai, the other one would be in North Mumbai within a radius of about 100 kilometers, right? So that way, if one AZ goes down due to a natural calamity, the other AZ would still be available to support. Full region failure is something which is very, very remote, and it's not the possibility of that is very, very remote. By launching instances in separate availability zones, you can protect your applications from failure of a single location, right? I mean, when you just deploy all your applications in one availability zone, and what if that availability zone goes down? Then you will lose your application, or there'll be an outage to your application. But if you deploy it in multiple availability zones, even if one AZ goes down, there's another AZ which is available to support your workload. Okay, and this is an AWS region. Within an AWS region, you've got a VPC within, and there are different availability zones, availability zone A, B, and C. Okay, and within each availability zone, you create subnets and you provision EC2 instances within that. Okay, so that's a very brief recap of what we learned yesterday, which is the basics of VPC. So now let's go to other important topics within the VPC. Okay, so now that you have created VPC and you've provisioned subnets and you have defined the IP address, now who's going to tell the VPC, or who's going to tell, when traffic flows through the VPC, who's going to say that, okay, go this way, right? You're supposed to go this way. You're supposed to go this way, right? I mean, we have signboards in a real traffic, right? And when you go outside, if you are in a public transport. Sorry, what was that? Was that a question?
So is that IP address which directs the flow of traffic?
No, I'm coming to that. I'm going to explain that concept, yeah? Okay, so now when you have a traffic, right? I mean, obviously there's going to be some sort of a signboard that says, right? I mean, in order to, I mean, I can speak about Hyderabad because I live in Hyderabad, right? I mean, and if I go to, say, Ameerpet, right? I want to go to Ameerpet, say from Pragati Nagar or Kukatpalli, right? I mean, so I go till the Y junction, and then it says go straight, right? I mean, in order to go to Balanagar, take a left, right? I mean, if you want to go to Jubilee Hills, go straight, right? So from Jubilee Hills, take a right to High-Tech City, right? So that way, there's some sort of a signboard, that gives you directions to, how to reach to a specific destination, right? So remember one thing very clearly: there is a source, there is a destination, right? Always there is a source, there's a destination, right? I mean, if I start from my source and I want to reach a destination, I need some sort of a guidance that tells me that go towards this destination, and this is the route that you should take, or this is the route that you should take. Okay, so from that perspective, okay, this is what we did yesterday. Forget about this EC2 instance, but this is what pretty much we did. I hope all of you were able to complete this lab exercise, right? Okay, so now, I mean, I just thought of giving you a pictorial representation of how this works, correct? So now I want to go from, say, JNTU to Secunderabad, right? I can actually take multiple routes, correct? I mean, I can take this route one, which will take me through this multiple different hops, right? Each one is a hop, correct? I mean, from JNTU to KPHB is one hop, from here to here is another hop, and this is another hop, right? And I can take a bus, right? A public transport RTC bus I can take. And then eventually I reach my destination, right? I can also take a different mode of transportation, right? There's also metro in major cities, all the tier 1 cities, there is a metro, right? And you can take a metro, and metro will have its different route, correct? I mean, it will probably follow the same route, or it will have a slightly different route, but the hops will be slightly different, okay? So now, if you see, these are the routes, correct? I mean, these are the routes that you have, and you can choose these routes. I mean, when you also put your Google Maps on, you can choose these routes and you can take the most efficient route for yourself, right? Same thing applies even in computer networks, right? So now when you have a network which interconnects multiple smaller networks, or which interconnects various different devices, computers, servers, and so on and so forth, right? and each one has got an IP address of its own, correct? Because I said, I mean, all of us have got some name, correct? I mean, and we are identified by our respective names, right? So now similarly, there is an IP address which is associated with every other system or computer or server in the network. And IP address is the way to uniquely identify a device in the network, correct? So from that perspective, if communication needs to happen between one IP address and another IP address, right? It will flow through the network, actual network, correct? I mean, it will flow through the copper, or it will flow through the fiber optic network that you have, right? And eventually it will reach some place, and that place will route it to another location as per the destination. And then eventually it will reach the final destination. Okay, the same thing applies there. So now in VPC, okay, if you take a traditional network also, you've got routers, correct? Let's take your home router. Okay, all of us have got internet connections, right? And we saw that yesterday that there's also a private IP address associated with my laptop or desktop when I use my laptop or desktop to browse the internet, right? So now, how does that get routed, right? You've got a router that is connected to your telephone line, right? You've got a telephone line and the router is connected to the telephone line. And what happens is, when you want to say browse google.com or aws.amazon.com, right? So now aws.amazon.com resolves to an IP address at the end of the day, because IP address is the one which is used to which is used for identifying, where the packet should flow, right? Because that's the name, right? I mean, if somebody calls me by a different name, I may not respond, correct? I mean, somebody has to address me by my right name so that I'll be able to respond back. Or I may have an alias, right? I mean, instead of calling me by my full name, I may also have an alias, right? So now the domain name that you see, which is aws.amazon.com, microsoft.com, google.com, right? So these are called domain names, right? They're called DNS. They are resolved by a system called DNS, domain naming system, right? So now the DNS maps a particular domain name to an IP address at the end of the day, right? So that way it resolves to an IP address. Everything has to get resolved to an IP address at the end of the day, right? Remember that, right? I mean, don't get confused with the domain names that you see, but at the end of the day, any packet what is a packet? A packet is basically a data bundle. It's a bundle of data, right? I mean, when systems communicate with each other over the network, what is the underlying protocol that it uses? It uses TCP/IP. Okay, TCP/IP is the standard protocol that it uses to transmit data over networks from a source to the destination, right? So now, if you look at the TCP/IP, TCP/IP actually breaks down a complete data. If I want to send a 100 MB file from location A to location B, the 100 MB file is broken down into multiple packets, and the TCP/IP sends those packets from destination A to destination B. And then once it reaches the destination B, all the packets are put together and the file is downloaded to the system, right? The destination. Okay, so now every packet that flows through the network, has to have some sort of a destination that it can reach. Okay, so from that perspective, IP address is very, very important, right? And at the end of the day, everything resolves to an IP address. Remember that. So VPC also works in a very similar fashion, because in a VPC, there is a private network that you built within AWS, but you have to also tell the VPC that how to route the traffic. Okay, like how you would do in a private network, right? I mean, how you would do in your home system, home router, right? In your home router, when you set up your router, I mean, these days the routers come fully set up, right? You don't have to do anything. You just start the router, put a key in your username, password, right, from the ISP, and then everything starts working, and then it will have a Wi-Fi password, and you use that Wi-Fi password to connect your device. So when your device gets connected to that router, and when your device wants to communicate to google.com, it will first send the packet request to your router. The router will have a route which will say that if it is google.com, google.com, send the traffic to this path, right? And you are also setting up a network within your house network, right? I mean, you are setting up, say, you have a storage device at your home, right? And you want that storage device to be accessed by all the computers, or you're setting up a small office network at your home, right? Your 3 or 4 of your friends are, planning to do work from home, right, from your place, and you want to set up a small office network and share the internet connection, right? Even in that case, you want to have some sort of a common file system, right, and things like that. You can go ahead and do that, right? So now in that case also, every traffic will go to the router. Router will decide where to send the traffic, right? Which direction to send the traffic, right? Same thing happens in VPC as well. When you set up your VPC, you also have to set up the route table, right? And you have to say that what is the target and what is the destination. These are the two terms that you need to understand. Okay. So now you see this, route map. Okay. Now, similarly, just imagine the same route map works even in the computer networks in VPC also. Okay. So now what happens is you always have to specify a destination. Okay. In the case of our VPC, we have 10.0.0.0/16. Okay, that is our VPC that we created yesterday, correct? So that will be the destination. Okay, any traffic that comes to the destination as 10.0.0.0/16. Okay, what it means is any packet that has got an IP address as a destination within this range. What is that range? It is 10.0.0/16. If I open CIDR.xyz, 10.0.0.0/16, right? So if you see, this has got 65,536 IP addresses, starting with 10.0.0.1, 10.0.255.254, correct? So now, if there is any packet that comes with a destination as one of these IP addresses within this 65,536, then send the traffic on this particular target. Okay, target is nothing but one of these routes. Okay, one of these routes. It can be the target. So it will send it to this target, and from here it will just traverse through this path, and then it will reach this destination. Okay, that it's a simple semantic definition that you're telling, saying that if the destination is so and so, then put it on this target. Okay, if the destination is different, then put it on this target, right? It can be a different thing, right? I mean, in this case, I may also want to do something else like this, correct? Instead of this, I may want to say, okay, this is, say, high-tech city. This high-tech city, correct? With a different destination, right? I mean, this destination could be something else. This could be, say, 10.0 or 192.168.1.0/16 or 0.0/16. Okay, it's one of the IP addresses, right? I mean, this will be 10.0.0.0/16, right? So these are the two destinations that it has, right? So now, if it is destination has an IP address from one of this range, then put it on this route. If the destination has one of the IP address from this range, put it on this target. Okay, that's the way a route table works. Okay, so don't get confused. It's very simple. There are two terminologies. One is called destination, the other one is called target. Destination, as the name suggests, by the definition, destination is the actual destination. Target is the route which it needs to take for that particular destination. Okay, so now, if I go back, okay, if I go back, you can attach a route table to your VPC, okay, which has this definition. Route table is nothing but a simple list of rules that says what is my destination and which target it has to go. Okay, so now there are some default targets that a VPC has. which is called local, right? I mean, it's called local. The local is within the VPC, right? If it is 10.0.0/16, then the target would be local. Okay, so now what does local mean? Local means that it has to be, the packet has to be circulated internally within the local zone, which is within the VPC. That is called local. It need not cross the local. Okay, it has to stay within the local VPC ranges. Okay, that is what a local means. Okay, so now when you have a destination as my VPC CIDR range, which is 10.0.0/16, it means that it is local. So which means that an EC2 instance present within my availability zone, which is the subnet one, it can have an IP address of 10.0.1.10, because our IP address CIDR range for subnet one is 10.0.10/24. Now this IP address will be within this range, within this subnet range. And here it is 10.0.20/24, which is and an IP address from this range is 10.0.2.15. Okay, so now this guy has to talk to this guy. This EC2 instance has to talk to this EC2 instance, right? It is like talking within the own premises. Okay, communication within the own premises. Okay, because it's all within the same VPC, correct? Within the same VPC, there are different availability zones. Each availability zone can be mapped to a subnet, and this EC2 instance has to talk to this EC2 instance, but which is all within the same IP address range, right? This is the mother. This is the mother. Consider this as the mother, right? So now this has to talk within the same, hierarchy, correct? So from that perspective, if you see, this will get routed through a default route that will say that it will be 10.0.0.0/16. Then it has to be local. So the moment you say local, it means that the communication will be done within this VPC. Okay, it will be done within the same VPC. Okay, so just give me a second. Yeah, so it has to happen within the same VPC. Okay, so that's the meaning of local. Okay, so now you may wonder, right? I mean, if I have this, then how will I, talk to say other networks? Okay, and let's say my EC2 instance wants to talk to Google. How will it talk to Google? How will it browse Google? How will it browse aws.amazon.com, or how will it browse the internet? Okay, that is where there is something called an internet gateway. Okay, an internet gateway is nothing but see, now let me go back to the example of your private premises home, right? You've got a router at home. Okay, the router, you can connect multiple devices to your router. Okay, and each device will get an IP address 192.168 something. So now if each device has to communicate to each other, then it's good, it can use this local route. Okay, but what if devices will need to connect to talk to internet? So then your router should have some sort of connectivity to the internet, correct? And it needs a modem. Okay, so then a modem comes into picture, and the modem will be able to connect your network to the internet through an ISP, right? The ISP can be an Airtel, it can be Geo, or it can be whatever, right? Hathway, if it's a cable, if it can be a Hathway, right? So now that's where it can talk to the internet, right? So now consider the internet gateway within the VPC as your modem, okay, which has some sort of a connectivity to the internet, right? In your case, it will be a Airtel or a Geo connection, correct? So unless and until you have an Airtel or Geo connection, you won't be able to talk to the internet, correct? I mean, you can always set up a local network using your router. Even if you don't have an internet connection, you can still set up your local network. But if you need internet connection, you need to subscribe to Geo or Airtel and then get connected to internet. Okay, so now that is where there's something called internet gateway within our VPC. Using the internet gateway, you attach that internet gateway to the VPC, then your VPC can have internet connectivity to internet through the internet gateway. So then your EC2 instances will be able to talk to, to internet. It can browse sites, websites, and so on and so forth. Okay, but there's also a route that needs to be added in the route table, because you're not giving a destination, right? I mean, for example, if you assume that only this route is there, right? 10.0.0/16. So now any packet that comes with a destination with as 10.0.0/16 will get routed within the VPC. Okay, but what about the other packets? Okay, for example, if I want to browse google.com, what is google.com's IP address? Okay, you can do an NS lookup, google.com. It'll tell you the IP address. Okay, this is the IP address of Google, at least for me. Okay, it may change for you depending on the location where you are, because Google has got wide network. They've got multiple edge locations, so it may come serve from different edge locations. But if I say ping-a google.com, right? If you see this 142, 250, 250, 67, 142, this is the IP address, correct? So now if I go back to my route table and see, this is the destination where I want to send my packet to, correct? Because I want to browse google.com. Now I don't have a specific entry in my route table that has this destination, because the only destination I have is 10.0.0/16. And this is a different range altogether, right? It is 142, 250, 67, 142. It is not there. So now if I don't have a route in the route table, the packet will get dropped, because it will check the route table for the route. And if the route is not available, it will simply drop the packet and it will say that I am dropping, and you won't be able to browse google.com, right? But the other thing is, you will have many such IP addresses to browse the internet, right? Like IPv4. How many IP addresses does IPv4 has? IPv4 number of addresses. It is how many? 2 to the power of 32. Okay, it's how much it is? 42 crores. Oh yeah, 400 crores. 400 crore IP addresses are there in the IPv4, right? And your IP address can be one among this 2 to the power of 32. Okay, so that's where you will have. So now it is not possible for you to put everything here, correct? So now also this can be any different range. Also it can be other private IP addresses or other VPCs and things like that. So that is the reason you have a notation called 0000/0. What does this mean? 0000/0, right? This is a known IP address, right? Which has got a destination. I know the IP address and the destination is given, right? So now this is a very specific IP address that I'm giving, very specific range that I'm giving, which will get routed to this target of local. So now in many cases, I don't even know the IP address of where I want to go to the destination. I only know the domain name, like google.com, amazon.com, right? And microsoft.com and so on and so forth, LinkedIn, facebook.com and so on and so forth. I only know those names, right? And eventually that name will get translated into an IP address through the DNS resolution mechanism, right? I'm sure a lot of you will be aware of what a DNS resolution mechanism means, right? You can read about it, right? And so in that case, what you need is anything that is not specific, right? Anything that is not specific, which gets resolved, it will go to this particular rule. So which is rule number 2, right? And it will go to, because it's an unknown, right? What does 0000/0 mean? which is a not specific. It's not a any specific IP address, right? It's an unknown IP address. It can be anything at the end of the day, right? It's like this, right? You know that, I mean, you're doing a function, okay, an event, and in that event, right, you are basically splitting the audience as two different types of audience, right? So one well-known audience, okay, and you know those people and you have their details, uh, and you probably would give them some sort of a badge, right, an yellow badge, who are well-known audience, right? And also at the same time, you are extending that event to public, right? Anyone and everyone can join that event. In such cases, you are giving them some sort of a different badge, a blue badge or whatever it is, correct? So now you have two different types of queues, one for yellow badge and one for blue badge, right? To enter into the audience into the event venue, right? For the audience, right? So it's like this, right? I mean, anyone and everyone is 0000/0, but the people that you know are 10,000/16, right? So now you want, this basically is a route that you want to, that is on the internet, right? And any website that you want to browse will actually fall under this category, because this can be anything other than this. This is a very specific route. This can be anything other than that, right? So from that perspective, I want to basically route it to my internet gateway, right? Because it has to go to the internet gateway. From there, it has to go to the internet. My internet gateway is like my Airtel or Geo connection. That will be IGW. Okay, so that's the way your route tables work. Okay, so remember, always remember, right? When you want to specify a destination, which is a well-known destination, which is within my VPC range, use then specify the actual CIDR range. Okay, always a destination will be CIDR ranges only, right? It can be a specific IP address also, but it has to be given in the form of a CIDR range. And for example, if you want to mention just a specific IP address, then it will be /32. Okay, 10.0.1, say 100. Sorry, somebody has to go on mute, please. Yeah, it is 10.0.100/32. When you say 32, it is just one IP address, which is that IP address. Okay, when you say 10.0.100, if you want to represent it in a CIDR fashion, in the CIDR notation, then you have to give a /32, right? You can also do that, but anyways, I mean, let's not worry about that. So it has to be in a CIDR notation, and it has to have a target. The local target means that it is within that VPC, right? Any packet that comes within the VPC will get routable within the VPC, which is through that local route. Okay, and by default, when you create a VPC, when you create a route table, this entry that you see 10.0.0/16 or whatever is the VPC's CIDR range will have this entry, the default entry of local, always available. You won't be able to delete that default entry, because if you delete that, if AWS allows you to delete that, then you will lose all connectivity to your VPC and you won't be able to even use that VPC. So that is the reason AWS by default, they create a route called 10 for that particular destination, which is the VPC CIDR range, and the target would be local, which means that AWS, the underlying technology, routing technology within the VPC knows that if it is local, then it has to be routable within that VPC, right? Like different EC2 instances and different subnets will be able to talk to each other. That's the meaning of local. And if it is anything other than that, then it will be IGW. It has to go to IGW, which is Internet Gateway, which is 00. Or I can also add a third route, which says, if it is for a different VPC, imagine there is another VPC apart from this, right? This is my VPC. There's one more VPC called my VPC1 with a CIDR range of 192.168.00/16. Okay, 00/16, right? And you want to basically route it. Okay, in that case, you need to establish a connectivity between this VPC and the other VPC, and there are different mechanisms to do that. One is called a VPC Pairing. You can pair two VPCs together. Or there's also a service called Transit Gateway. It can be a transit gateway, right? You can use the transit gateway to route traffic from one VPC to another VPC, right? So that will be either this will be peering or transit gateway. Okay, so that's the way it actually works. Okay, so now remember this. Let's go back to our lab, right? I'm going to show you something. If I go back to my VPC console, I will show the VPC that I created yesterday. This is the VPC I created yesterday. Okay, and this is the VPC with a range of 10.0.0/16, and it has got two subnets in two different availability zones, subnet 1, subnet 2. Right? If you see, one is in 1A, the other one is in 1B. Okay, and if I go to a route table, okay, when I create a VPC, there is also a default route table which is created. Okay, this is the default route table which is created. It has a route table ID, and every resource in AWS has got an ID associated with it. Okay, if you see, this is the subnet ID. This is a unique ID. VPC has got a VPC ID. Right? This is the VPC ID. This is a unique ID. Okay, so now let me go to the route table. If you see the route table, this is the default route table, and this is the main route table. Okay, this is the main route table. You can create additional route tables as per your requirement, but let's do that later. For now, if you see this this is associated with my VPC, and this has got a couple of things that you'll have to closely look at, right? One is it has got a route list of routes. Okay, and if you see this, it has the same thing, right? Destination. What is the destination? It is 10.0.0/16. Target would be local. Okay, if I say edit this route, I will not be able to delete this. I will never get an option to delete this. Okay, I will never get an option to delete it, but I can add more entries to this. Okay, I can add more entries to this, such as it can be a particular, it can be one of these, right? The targets can be one of these. The target can be an EC2 instance, it can be an internet gateway, it can be a NAT gateway, it can be network interface, and so on and so forth. Peering connection, transit gateway, so on and so forth. Anyways, we'll come back to this later, and I'll have an option to delete that, but I'll never have an option to delete my default route, which routes it to local. Okay, I won't be able to change this either. Okay, just cancel this, come out. In a route table, you can explicitly associate a subnet. Okay, because at the end of the day, remember what I said yesterday, a VPC is a logical construct, okay, which has got an IP address range, but a subnet is a physical thing, right? Because within the subnet, you are mapping a subnet to an availability zone, and it is within the subnet you will be able to provision EC2 instances or other resources, right? You won't be able to directly provision it in a VPC, right? I mean, imagine a VPC is like your apartment, right? Imagine you buy a 1,500 square feet apartment, which has just got 4 walls. Okay, it just has 4 walls, nothing else in it. Okay, is it? Will you be able to live in that? It has got just 4 walls, nothing else. A roof and a 4 walls and a floor. That's it. It has got nothing, absolutely nothing in it. Will you be able to live in it? Okay, it is needed. I mean, the 4 walls, roof, and the floor are required. But apart from that, you also require rooms in it and some amenities in that rooms in order for you to live in that apartment. Correct? So imagine a VPC is like that: 4 walls of an apartment, 1,500 square foot apartment with a roof, 4 walls, and a floor. Nothing else in it. But within that 1,500 square foot, you can say that, okay, I will have my living room for 300, 350 square foot is my living room, right? Another 200, 250, I will split that into 3 bedrooms, a kitchen, bathrooms and so on and so forth, right? And then you will have amenities in it, and you will also have doors to each room, correct? So imagine each room is like a subnet. Okay, so now a room is where you actually sit and do work, right? And you have a dining hall, right? So that you can have your food like breakfast, lunch, dinner, and so on and so forth, right? So now imagine, right? So subnet is the one actual, it's a physical entity, right? I mean, room is like a subnet, it's like a physical entity, whereas the four walls of your apartment is just a logical entity. Okay, so now within that subnet, right, you can now, when you create a route table, you got to associate that route table with the subnets, so that the traffic that is originating from a subnet or destined to a subnet, the route table will be able to say that, okay, so now this subnet has got this rule that if it originates from this subnet, then it has to be routed internally within the VPC, or it has to get routed to the internet. Okay, so that way you know exactly at a subnet level, because that's the physical entity. Okay, so from that perspective, if you see in the main route table, you will have any route table, you will have these two sections. Okay, what are those two sections? Let me just expand this. Yeah, so what are those two sections? You've got a section where you can explicitly associate a subnet to a route table. If you don't explicitly associate a subnet with a route table, by default, all the subnets in your VPC will get associated with the main route table, right? And you won't be able to delete this main route table, right? By default, every VPC, every subnet within the VPC will be associated with the main route table with whatever routes that are configured here. Okay, so now a traffic that originates or is destined to any of these, right? The rules that are applied here in this route table will be applied to all of these subnets. Okay, like for example, in this case, a EC2 instance from this subnet 2 wants to talk to subnet 1, right? So it will get originated from this particular EC2 instance. So now it will come to the main route table. Okay, so the main route table will have the subnet associations, right? In this case, both the subnets are associated with this main route table. Okay, so it knows that it has to get processed through this main route table. So it will come to this route table and it will see, okay, what are the rules that needs to be applied here? Okay, in this case, the destination is 10.00/16. Yes. Is it within this destination? Yes, it is within this destination. Then what will be the target? The target will be local. Okay, so it will go to this particular target, which is called the local. So which will be routed within this VPC. Okay, so that's how it gets routed. Okay, so now two things to note, right? Every VPC will have a route table, a default route table, which is called the main route table, which will have all the subnets associated with it by default. If you read this very clearly, you'll understand. The following subnets have not been explicitly associated with any route table and are therefore associated with the main route table. Now, if I create a new route table under this VPC, and if I associate one of the subnets to that, then it will go away from this. It will go away from this and it will get associated with the other route table. And you can create customized rules within that particular route table. Okay, but remember, always a subnet can be associated with only one route table. There is a one-to-one mapping between subnets and route tables. It is not one to many, or it is not many to many. Okay, I can show you that. If I create a new route table, don't get confused right now. I'm just creating a new route table saying new route table for this VPC. I'll just create it. If you see this is a new route table that I've created. Here, if you see, you have a tag here called main, correct? This is not main, this is the main route table, but this is a secondary route table that I have. So now I don't have anything associated with this. Okay, so now if you see this, there's nothing associated explicitly with this, but you see this message here. The following subnets have not been explicitly associated with any route table and are therefore associated with the main route table. So these two subnets are associated with only with the main route table, not with the secondary route tables. And if you see the route, it will have a default route. Even the new route table will have a default route, which cannot be deleted. So now what I'm going to do is I'm going to edit this subnet. I'm going to say subnet 1, go to my new route table. Okay, so now if you see, the subnet 1 is associated with my new route table. Okay, and it will go away from my main route table. If you see this, if I go to my main route table, it will go away from my main route table. My main route table only has got subnet 2 associated with it by default. So that way, a subnet and a route table association is always one-to-one mapping. It can never be one to many or many to many or many to one. Okay, it is always one-to-one. If you have a route table, if you have a subnet, the subnet can be associated with only one route table. And whatever rules that applies for that route table applies to that subnet. Okay, anyways, let me just go ahead and I will remove this so that there's no additional confusion. Let me just remove this. I'll say edit subnet association. So I'll just uncheck this and save it. Yeah, it will go away. It will go back to my main route table, right? So now I'm just going to delete my route table. The secondary route table, I'm just going to delete. Okay, it's deleted. Can we delete the main route table? No, you will never be able to delete the main route table. If you see, note that the following route tables cannot be deleted because it has got an association and it can never be deleted. The main route table will always stay, because if AWS gives you the option to delete the main route table, then your entire VPC networking will go for a toss and your VPC will not be routable. The traffic within the VPC will never get routable. Okay. Okay. All right. So now let's come back, right? Let's go to internet gateways. Okay. So now you need an internet gateway, correct? I mean, we saw about this, right? I mean, right now, this route is there. So it's only routable within the VPC. But now what if I need an internet connection to my VPC? So that is where you need an internet gateway. So you go to this internet gateways. And before going to internet gateway, let's see what an internet gateway is. Let's read the definition of an internet gateway. Yeah. An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet. An internet gateway serves two purposes: to provide a target in your VPC route tables for internet routable traffic, and to perform NAT for instances, network address translation. I don't know how many of you are aware of it, but you can just read about it. It's called network address translation, because what happens is when there is a router in the middle, what the router does is, if you're browsing, say, google.com or AWS Amazon.com, what your router does is it takes your private IP address, okay, and then when it goes out through the router on the modem, it goes out as your public IP address. Okay, public IP address is the one which is associated with your internet connection, right? All of us have a public IP address. I showed you yesterday what is my IP. If all of you do this in your own respective computers, open Google and just search what space is space my space IP, you will get an IP address like this. And this changes from person to person, from connection to connection. This is your IPv4 public IP address. Okay, a public address is nothing but okay, it's like this, right? Let me give you one more analogy, right? In order for you to understand what is the difference between a public IP address and a private IP address. Okay, you have an office. So now in the office there will be different, there will be multiple workstations, correct? Desks or cubicles. Each workstation or cubicle will have a phone in it, correct? Because it's needed to communicate with each other within the office, right? If I want to speak to somebody in third floor, I just need to dial the extension and speak to that person in the third floor, right? The moment I dial the extension, it says it goes to that particular person. It rings in at his desk phone, and he answers it, and I speak to him. Okay, that's the way I communicate within the office. Okay, within intra office. So now say, for example, I want to call somebody outside my office, right? What I do, I press usually some 9 or 0, right? And then I dial the actual mobile number or the phone number, and then it goes to outside my office, correct? Similarly, somebody wants to call from outside to me, right? What they do, right? They can't directly dial my extension, correct? Okay, from somewhere from outside, they want to call me, my desk phone at office. They dial a number, actual number, right? Which will be a whatever 8-digit number or a 10-digit number. They dial an 8-digit number along with an STD code or whatever it is. It comes to my office, and within the office, there will be a IVR system that says, please dial the extension that you want. Right? So then he dials my extension. Then it gets routed to my phone. Okay, my desk phone. And then I answer it. Then I'll be able to speak to that person who called me from outside. It is very similar, correct? Public IP address is like the actual phone number of my office, correct? The actual phone number of my office, which is accessible from public. Whereas extension number, a 4-digit or a 3-digit extension number, 6-digit extension number is like my private IP address. I can only dial privately within my office network. I won't be able to dial the private number from a phone booth or from a mobile, right? It'll not be recognizable. Okay, but in order for me to recognize my actual this thing, I have to dial the actual phone number of my office, which will ring, and there will be an IVR system which says dial the required extension, and then it will get routed to my desk phone. Okay, it's very similar. So now in this case, if somebody wants to reach out to me, they have to actually reach out to this IP address, and it will come to my modem or router. Then the router will have a route that says, send this traffic to so-and-so computer, or the other way around, right? The other way around, if I browse some google.com or whatever it is, the traffic first goes to the router. The router will have a route that says, if it is 0000/0, then take it to the internet. But when it goes to the internet, it does not go as my private IP address. My private IP address can be 192.168.1.10. But my public IP address is this 49.37.168.121. So there will be a translation of IP address that happens. It's called natting. Okay, IP address translates from a private to public, and eventually when it goes out as my 49.37.168.121. Same thing happens even in your office phone, right? When I call a mobile number from my office desk, I first need to dial 0 or 9, and then I'll dial my mobile number, right? And the mobile number. And when it finally appears on the destination mobile number, the person whom I'm calling, it will be the actual office phone number. It won't be your extension number, right? Always try that. I mean, if you have, if you are working currently, or if you have somebody, if you know somebody, or if you have a small office of any of your relatives, you can try that. Who has got an extension or private network, you can try that. It will finally go as the office number, which is the 8-digit along with a STD code. Correct? It will eventually go as that. So same thing happens here also, right? It will go as a public IP address. That is called natting. So your IGW has got the ability to perform network address translation that have been assigned IPv4 addresses. Okay, and there are no additional charge for having IGW in your account, and IGW can scale, right? I mean, if you are accessing internet, the IGW can scale automatically, and it can go to the extent to support your traffic. If you see here, this is a router. Always the symbol that you see will be a router. From within the subnet, there's an EC2 instance, which has an IP address of 10.0.0.6. If it needs to talk to internet, it will go through this. This is the IGW. This horseshoe that you see, the symbol is for an IGW. This is the internet. It goes to the IGW and it reaches the internet. Okay, that's called an IGW. So now for my VPC, there is no IGW. I first need to create an IGW. Let me create an IGW saying my IGW. I will say create an internet gateway. That's it. It's created. And you will also see attach it to a VPC, but let me come back to that, right? If you see this, I'm still searching. I mean, it's not able to find, right? So if you see this, this is the IGW which is available for my default VPC. Just ignore that. It's already attached to my default VPC, but the new IGW that I created cannot be used unless and until I attach it to my VPC. Okay, it is just created, but it is not attached. So what you need to do is you have to go to actions, say attach to VPC, and you have to select a VPC. So in this drop down, you will see only the VPCs which don't have IGWs. Again, VPC IGW is a one-to-one relationship. You can only attach one VPC to an IGW, and vice versa. You can only attach one IGW to one VPC. It's a one-to-one. So I select my VPC and I say attach internet gateway. Yes, it is attached. If I go to my IGWs, I remove the filter. This is my IGW which I just created. It is attached to my VPC. Okay, so now let me go to my route table. And if you see, this is my default route table. It has got just a default route of 10.0.0/16, right? And with no route to internet, right? It does not have an internet route, but we'll come back to that, right? So now let me go to EC2. Let me go to my EC2 console and let me provision an EC2 instance. Okay, there are no EC2 instance. Let me just quickly provision one EC2 instance. I mean, don't worry about it. There is a special class on EC2, and what are the options that you will follow while you provision an EC2 instance. We'll come back to that later. For now, just focus on route table and internet gateways, right? I'll just select this. Let's configure instance details. Okay, here I need to select my VPC, which is my VPC, and I also need to select an subnet where I want my VPC or where I want my EC2 instance to be provisioned. I have just provisioned it. Rest all, just leave it as is. Add storage tags, just say name my EC2. Yeah, so just review and launch. As I acknowledge, just say launch. Okay, it's provisioning a new EC2 instance. Okay, let's just wait for a few seconds for this to go in running state. Yeah, it's running already. So now if you see, if you closely observe this EC2 instance has got a private IP address, right? Because it's from the subnet 1, which is in the 10.0.1.2.21. Okay, it's a private IP address that I have, but it does not have any public IP address. So within the VPC, it is routable. But how will I be able to, connect to that? I won't be able to connect to this because it does not have a public IP address. Okay, it only has a private IP address. So if I'm there within the VPC, I'll be able to connect to that. But right now, I won't be able to connect to that. Okay, so now let's go back to route tables. So now this is where you need to add a route to the route table, which says add a route that says 0.0.0/0, and the target will be an internet gateway. Okay, the moment I select the internet gateway, I'll see my internet gateway which is available, my IGW, and then I'll click on save routes. Now it is routable to internet. Okay, but at the same time, my subnet that I have, right? So this the subnet 1 that I have, does not have the ability to associate a public IP address to my EC2 instance because the auto assign IPv4 addresses is not enabled in my subnet. auto assign IPv4, public IPv4 is called as no. Okay, so now I need to just go ahead and edit this and say edit subnet settings. Let me just refresh the page. Yeah, if I select subnet 1, I will say okay. I think there's a lot of change that happened off late on the console. Okay, so if I go here, just click on view details. Okay, let's come back to that. But here, if you see, this does not have a public IP address at this point in time. Okay, let's just go back to my whiteboarding here. Okay, so if you see this, I have an EC2 instance in availability zone 1. I have an EC2 instance in availability zone 2, subnet 1 and subnet 2. Okay, so now how the traffic flows, right? If you see the brown, for example, this has got a 10.0.1.142 and this is 10.0.2.125. Now, if 10.0.1.142 wants to talk to this 10.0.2.125, what is the route that it will take? It will take this route, 10.0.0/16, which is the destination, local. So the packet will come to this route table and it knows that it has to get routed to this EC2 instance through the local VPC's interconnectivity, correct? So it will just route the traffic to this particular destination. Okay, perfect. So now if this guy wants to talk to internet, then it has to have this entry in the route table that says 0000/0. It has to go to internet gateway. So the moment it has this route, this entry in the route table, then it will route it to the internet gateway. So we are going to see how it works. Okay, let me go back. Let me deprovision this. Let me delete this instance. Okay, I've deleted that instance. I will launch a new instance. Now that I have got a route in my EC2 instance, in my route table, 00002 internet gateway, and I also have an internet gateway. Okay, I will select my VPC. I will select subnet 1. I will just assign a public IP to my EC2 instance.
Hello.
Yeah.
Hello, sir. Stay on that page.
Sorry, which page? Sorry, I moved on.
Just there's a just pop up of a dialog box. We selected options.
No, I will come to that. I'll come to that. Okay, let's do that later. Okay, that's on the EC2. But right now, I don't want you to focus on EC2. Okay, I want you to focus on what I'm teaching right now. Okay, my EC2 instance, because there's a special class on is how EC2 works and what are the settings in EC2 and how do you provision an EC2 instance. Okay, let's come back to that later. But right now, just focus on what I'm focusing on is the VPC route table and internet gateway. Okay, so now I provisioned an EC2 instance. Now, since I've got the route and I also associated a public IP address to my EC2 instance, this is the public IP address of my EC2 instance. Okay, 3.110.159.185. If I go here, yeah, this is the one. Let me just connect to my EC2 instance. Don't worry about this. I'm going to teach you in detail how to provision an EC2, how to connect to EC2 through PuTTY or through any other terminal. Okay. Okay, so now I'm connected to this EC2 instance. I'm logged into the EC2 instance. So now I can say ping google.com. Okay. What will be the response? See, it's giving me the response, correct? I'm able to ping the google.com. So there is internet connectivity there. Okay, I can also do curl google.com. I don't know how many of you are aware of this commands. Ping is to check the network connectivity between the source and destination, right? Whether the destination is able to respond or not. Curl is to browse a particular website from Linux, okay, from a Linux terminal. Yeah, if you see curl, it's able to respond back, right? It throws me the HTML page. Provided if this is a Windows EC2 instance, I'll be able to open a browser and show you, browse the internet and show you. But this is not it does not have a browser. It does not have a graphical user interface. It just has it's a Linux. It's an Amazon Linux instance. But net, it is able to browse the internet and it's able to get a response from the internet, correct? Okay, so now let's go back. So now the reason why it's able to browse the internet is because in my route table for that particular subnet, okay, what is that subnet? This is the subnet. This is the route table that I'm using, right? So this has got two subnets associated with it. 10.0.10/24, 10.0.20/24. My both subnets, and it has got a route that says 0000. Anything which is 0000 has to go to internet gateway, and it has to be routed through internet gateway, right? Let me provision one more EC2 instance, which is again a private one, to just show you how the interconnectivity works within one EC2 instance and another EC2 instance. Okay. This will be name my EC2 -2. I'm enabling ping to that, okay, so that it works. Okay, this is the second EC2 instance which is being provisioned. It has got only a private IP address 10.0.275. Okay, let it come to running state. So then I can ping this EC2 instance and see if it is able to ping. If it is able to ping, then our destination, this brown route that you see, right? This EC2 instance is able to communicate with another EC2 instance. That should work fine, right? And it goes through this route entry, which is 10.0.0/16, which is the destination, and local is the target, which is the local VPC's routing mechanism. Okay, so this is the one, and this is 10.0.275. Okay, it's running. So now what I'll do is I'll try to ping that IP address. Ping 10.0.275. Yeah, it's able to ping. See this. Okay, so that way you see this works fine, right? I mean, this EC2 instance is able to talk to this EC2 instance, and it goes through this particular route entry. Okay, so now let's make slight modifications to the route table. Okay, I'm going to go back to my route table, and I'll not be able to delete this. Okay, I won't be able to delete this, but I can delete the other one that I created, correct? Which is my internet route. This is my internet route. 0000 is my internet route. I mean, you can't call it an internet route. It is anything other than 10.0.0/16. That's the way you have to look at it, which is anything other than this. Okay, I'm going to delete this and save. Once I do that, I will actually lose connectivity to my EC2 instance. You see, I'm not able to, I'm not able to access this because I lost the connectivity. Because that EC2 instance is cut off from the internet. See, it said broken pipe, send disconnect. It's a broken pipe. And even if I try to do a SSH into that, it won't be able to SSH. It will say connection timed out after some time because that EC2 instance is cut off from the internet because I removed this entry, this route I removed. So even though I have an internet gateway associated, I don't have a route rule that says that anything which is 0000 go to the internet gateway. So even from outside, I won't be able to access my EC2 instance. Even from my EC2 instance, through some way I'm able to log into the EC2 instance, I won't be able to browse the internet. Okay, so now let's do one thing. See, if you see this, it'll just wait for a minute or two. It'll do its retries and it'll say connection timed out after some time. Let us just wait for the connection timeout, and then let us add the route back. Let us add the 00 route back. Okay, anyways, it's not working. So let me just kill this. If you see this operation timed out, see, it waited and it said operation timed out. Okay, so it's not able to access, correct? Okay, so now let me go back. I will again add that entry back in my main route table that belongs to my VPC, which is 000/0. And here the target that I need to give is internet gateway because it has to go routable over the internet, right? That is what is the job of an internet gateway. And I'll say save routes. Now it's done. So now let me go back and I'll again do the same SSH. See, it's connected. Okay, so now it's very simple. If you want your EC2 instances to be routable over internet, then you need an appropriate route which says 0000 as the destination and the target to be internet gateway. Okay, and once I'm inside, I'll be able to access my EC2 instance. Okay, so now if you see from my public EC2 instance, this is my public EC2 instance, which has got a public address associated with it. This is my private EC2 instance because my EC2 instance, which is just a private, it does not have a public IP associated with it. Okay, I won't be able to access my private EC2 instance from public internet, but I'll be able to ping. Once I'm in this EC2 instance, from this EC2 instance, I'll be able to talk to this EC2 instance, which is a private, which is where you did the ping of 10.0.275, right? This is 10.0.275, which is my private EC2 instance. This is my public EC2 instance, which has got a public IP associated with it, 3.110.159.185. I actually connected to 3.110.159.185 through this, correct? This is what I connected to, and I'm able to log into my EC2 instance. From that EC2 instance, I can ping my private EC2 instance. So there is a connectivity, end-to-end connectivity that is established between my internet, my public EC2 instance, and private EC2 instance. Okay, so that's the way it works. Okay, for example, let me just blow this up, quickly recap. So this is communication between one EC2 instance and one subnet to other subnet. It goes through this brown route. Okay, communication between an EC2 instance and one subnet to another subnet. Again, the reverse route, right? If my subnet 2 EC2 instance wants to talk to subnet 1 EC2 instance, it'll again come here. It'll look at the route table. It'll have 10.0.0.16 local, and this will get routed back. Okay. If I want to browse google.com, then the traffic will go. It'll go to the route table. It'll check what is the destination. In this case, destination is whatever 142.250 an IP address which is outside of this range, the moment it is outside of this range, it will go to 0000/0, and then it will check what is the target. It will be internet gateway. It will route the traffic to internet gateway, and it will go out through the internet gateway. So the moment you say 0000/0 attached to an IGW, that route table becomes a public route table, or any subnet that is associated to that route table becomes a public subnet. Okay. You can also, as I said, you can also add additional subnets, right? You can create more subnets. I can create a new route table, and I can say private route table, and VPC will be my VPC. I'll just create it. So in this case, I can go to the subnet association. If I go to the private route table, I can go to subnet associations. I can make subnet 2 associated with my private route table, so that my subnet 2 is private, subnet 1 is public. That's the way I want to look at it. My subnet 2 is now private. And if I go to my main route table, this is my main route table, where in the main route table, I've got only the subnet 1 associated with the main route table, which has got a route to internet. So since it has got a route to the internet, it becomes a public route table. This is a public route table. This is a private route table. Okay, that is what happens here. So this is a public route table. Since it has got an internet route, a private route table will only have a local route. It will not have a route to the internet. So the moment I associate my subnet, which is my subnet 2 is associated with my private route table, so that subnet becomes a private subnet. And the subnet 1 is associated with my public route table, then it becomes a public subnet. So these are two important terminologies that you need to understand. It's a private subnet and public subnet. Okay, so don't worry about it. I mean, if you feel it difficult to absorb, don't worry. You just have to do some homework. You just have to create this a couple of times, test it out, right? Once you do it, then it works fine. Then you will be able to absorb these concepts. But I mean, you can always, watch this recording offline in case if you're stuck, right? And you can basically try to absorb these concepts later also. Don't worry. But remember that there are private subnets and public subnets. A public subnet is the one which will have an internet routable entry route table. Okay, it will have an internet routable entry in the route table, which will point to the internet gateway. Private subnet does not have that rule. So that's why it's called a private route table. And if you see here, it is basically a subnet can be associated with only one route table at any point in time. Okay, for example, you have subnet 1 and subnet 2, it can be pointed to only one route table, right? It is not possible to do this. It's not possible to do this. Okay, this won't work. It's not possible. You can't do this. Okay, you have these subnets. Subnets can be associated to only one route table, but multiple subnets can be associated to one route table. That is possible. So many subnets can be associated to one route table. So there's a many to one relationship possible, but there's no many to many. Okay, so now let's go to the assignment for today. Route tables, internet gateways, I've given you links. Okay, and there's a list of steps that I want you to do today. Okay, which is mentioned here. Open the default main route table for the MyVPC that you created yesterday, and review the local route with the destination as 10.0.0.16. Understand what the local route means. Then create an internet gateway called MyVPC IGW. Attach the MyVPC IGW to the MyVPC. Open the main route table. Go to the routes. edit the routes by clicking edit routes, add a route called 0000/0. And from the drop down, select internet gateway and select the newly created my VPC IGW. Okay, this is what you need to do today. Very simple. Okay, but more importantly, read these concepts, understand these concepts by going through these links, and complete this assignment for today. Okay, and this video will be made available for today's session, will be made available, and you'll be able to watch this again and again, right, and understand these concepts, and more importantly read this, and also look at also compare it with the analogies that I've given you, right, the examples that I've given you, such as the route, the example that I gave you, right, and also look at imagine some of these, right, in real life, and then understand it and read it. So then I'm sure you'll be able to understand it. Okay, I'm going to give you this. I'll stop the screen share. I'm going to put this in the chat.
Sir, just a query, sir.
Yeah.
After creating this internet gateway, we were not able to assign this public IP, but how can we do that? That has been dropped, and you created a EC2 instance with public IP, so you're able to connect.
Correct.
But,
no, I'll come to that. I will come to that in tomorrow's session.
Sure.
Okay, a valid question, but just hang on till tomorrow. I'm going to explain that tomorrow. Okay,
Yeah,
for now, just understand that. Focus only on the VPC for now. Okay, focus only on the VPC and the the subnets and the internet gateway, route table, internet gateway. These are the 4 things that you need to focus. See, I'm actually taking it in a very, very structured way, right? It's like peeling the layers of onion. Okay, I don't want to go to the core of the onion immediately. I'll keep peeling one by one, layer by layer. I'll explain one by one, and then go to because that only then you'll be able to logically connect, and you'll be able to logically understand what concepts that I'm trying to explain out here.
Yeah, sure. Thank you.
Okay, all right. Sounds good then. So please get into your breakout rooms, right, and start looking into the assignment that I've given, and the recording will be made available to you later, and then you can watch it. And I'll also give you the PPT sometime. Okay, so let me see if I have.
Sure. One more doubt, sir.
I've got a full PPT, but only look at the ones that I explained you today and yesterday. Okay, I mean, don't look at the other things. It will confuse you. Okay, so just look at only the ones that I explained you today. Okay, just that you.
Yeah, Prasanna sir, yesterday from a lab session, there were a few open questions. Would you be able to take it now?
No, sorry, not now, because I have to get into a call right now.
Okay.
Okay, so do one thing, just keep your questions. I'm going to have a special doubt clarification session, right? Or if mentors, mainly Sharath and Sai Prashant, if you can address some of those queries, and if still they have more queries, I would request you to capture those, and let's do a special doubt clarification session sometime, and I'll clear those doubts.
All right, sounds good.
Or what we can do is tomorrow, first 15-20 minutes we can keep for doubt clarification, and then move to the next.
All right. Yeah.
Okay. All right. Thank you. Thanks everyone. Right. Have a great, good day. And I'll see you all tomorrow at 8:30. And please be on time.
Thank you, sir.
The participation has gone down. It's now 86 or maybe 80, 75. Please let your friends know that, these are some abstract concepts which they need to understand, but it's worth trying out. If some of your friends are thinking of dropping out, please persuade them to come back. Okay, because there's a lot more to learn. Okay, for whatever reason that they've dropped off, please bring them back.
Excuse me, sir.
Thank you. Thanks all. Bye.
Thank you, Anna. Sairam. Now you can drop off.
we'll work on that
Sure.
students'
Thank you.
queries. Anaya. I know you have a hard stop at 10.
Sure. Thank
Thanks,
you.
Anaya. Bye, Sairam. Guys, sorry, I had to stop. Someone is questioning something.
No, Chris. The only point is yesterday we are all doing that hands-on. Okay. As a part of that, there are a few very basic questions which came up.
Okay.
So which will actually remain open even if we do even today's practical session as well.
Okay.
So I'm actually requesting maybe Sharath and Prashant would before we going up with the breakout data sessions, would we actually be open up for a Q&A session now, so that at least if we can answer those basic ones, or maybe compile them for the tomorrow's doubt clearance session.
Sure, Anaya. That sounds good. So here is my opinion, guys. We'll start the breakout sessions, and who all have accounts cleared, and who all able to launch yesterday's services, right? So you all can go into the breakout room sessions and work on today's stuff if you have no showstoppers from yesterday. And then the remaining students who has a questions will stay in the main room, and one of the tutor like Sharath, Sai Prashant or Vijay, will engage one of them to clarify the same doubt if you have. Does it make sense, Mulyana? And to all the mentors, and also keep a note of questions. If it is the same recurring question from all the students, right? So let us know in our channel, in our communication channel via WhatsApp. Then we will assign one of the mentor to your group, one of the tutor to your group to resolve that issue.
All right, sounds good. Yeah.
Sure. I'm opening breakout room session, guys. Please join to breakout room sessions and try to finish today's task by within the breakout room session itself. And few students not renaming their profile ID with student IDs, guys, please do so. Sai Krishna Pola and Sony Shinde, I'm repeating to you guys every day. This is not a good sign. Please do not make me to announce every day to rename with your student profile. Sairam, Mentor Bharati, you have been assigned to room number 1, and you will have a co-mentor, Sunita Channa. Please do have an introduction with her. I'll be joining your group shortly.
Yes. Yeah. Thank you.
Sure. So Prerna, just stay here. Guys, can you all join to your breakout room sessions? Unless if you have any questions. Vijay bro, are you able to join, or you want me to reassign?
No, I'm just waiting. Yeah, for the confirmation. Yeah, okay. I could see. Yeah, let me join. Yeah, thank you.
Sure, Vijay bro. And Vijay bro, make yourself available for some time. Okay, I'll push you into one of the breakout rooms. I'll just be ready.
Sure. Yeah. Okay. Yeah.
Thanks, Vijay bro. Students, SB37, SG54, SG58. Do you guys have any questions?
Hi, Chris. I have a question.
Yes.
I have already an AWS account,
Okay.
but its time is over. It's 1 year.
Okay.
Can I use that account? Is there any chargeable?
So last time what we did is we just created another new email, and then we took or registered another account, new AWS account. That's what we tried last
Can
time.
you use this? Can we use in the credit card, like debit card?
Yeah, you can use your own debit or credit card. and I
It's
think it is
already used.
yeah, you can use the same card. Yeah, you can use the same card. I think it is a temporary hold of a couple dollars, and then you will get that back if you talk to a representative, like customer representative.
Yeah, they have given a $25 name open in that
Okay.
account.
Okay.
You can use that account. I don't know, is that-
I'm not clear with your ask actually. So you said you have a coupon from your existing account, right? $25.
Yeah, exactly.
Okay.
Yes.
Why do you need to use it? Because you don't get charged for anything, right? For the services
Yeah.
that we are using right now, so we don't need to pay anything, right? So
Yeah.
I don't think or instead of that credit and debit card, right? You can use that coupon to just launch new account.
Yeah, okay. Yes,
Vijay bro,
thank
మిమ్మల్ని
you.
నేను కోర్స్ చేశాను. యూ కెన్ యాక్చువల్లీ జంప్ అరౌండ్ డిఫరెంట్ గ్రూప్స్. విజయ్ బ్రో, మీ అంతా మీరు వెళ్ళొచ్చు ఇప్పుడు రూమ్ నెంబర్ 6 కి. 2 అకౌంట్స్ కి కోర్స్ చేశాను. మీరు జాయిన్ అవ్వండి రూమ్ నెంబర్ 6 కి డైరెక్ట్ గా. నేను అసైన్ చేయకుండా మీరు జాయిన్ అయిపోవచ్చు. క్లిక్ ఆన్ బ్రేక్అవుట్ రూమ్స్ అండ్ జాయిన్ టు రూమ్ నెంబర్ 6. మీరు మ్యూట్ లో ఉన్నారు ఇన్ కేస్ మనం మాట్లాడితే. అండ్ SG58, మ్యామ్, ఇట్ ఈస్ బీన్ రిపీటింగ్ ఎవ్రీ డే. You are not responding in the main session and you're being very quiet. This is something, we need to talk one-on-one. I'm putting you in the waiting room unless you want to speak about it. SG58, Ashwini Billu. SG32, ma'am, do you have any questions?